Hi everybody. Today we're going to be talking about writing equations of lines. So let's just start off by recapping our different equations of lines. We have the slope-intercept form, which is named appropriately because all you need is the slope and the y-intercept in order to write the equation of a line in slope-intercept form. Then we have point-slope, where again you see that we need the slope. So same as before, but this time you have a point, x1, y1 is any point on the line. So all you need to write the equation in point-slope form is the slope and any point on the line. And then we have standard form, which is ax plus by equals c. A, b, and c are integers, which remember what an integer is? It's just any whole number and its opposite. So for example, 5 is an integer, just as -5 is an integer, but is 1/4 an integer? No. Also, typically you have a is greater than 0, which means that it's some positive number. That can vary from book to book, so just double check with your teacher what they want you to follow. Okay, so these are our three types, and we're going to be talking about writing the equations of lines in these forms. So let's take a look at our first example. So more often than not, you're going to be asked to give the equation of the line in slope-intercept form. So here it says, give the equation of the line described in slope-intercept form. So remember, that's our y equals mx plus b. Okay, so when we're done, it's going to look like that, and we're just going to have something in for the m and something in for the b. Well, conveniently, they told me what the m is. It's 1/3, so I know I can just plug that in. And then b, remember, is the y-intercept. And y-intercepts are always given as 0, whatever the y-intercept is. So in this case, they gave me both the m and the b. So remember, I'm going to take y equals mx plus b, and I need to fill in these two things. Well, they told me the m, or the slope, is 1/3, so I can plug that in right away. I'll do that in blue. 1/3 x, and then plus whatever b is, but in this case b is a -4, so I'll do it as -4. And that's my answer. That's it. My answer is in slope-intercept form. That's the slope, and that's the y-intercept. That's as easy as it gets, but of course we make it a little harder from there. Let's look at this example. Here they give me a slope of -2, but the point is not a y-intercept anymore. Now it's just some other point on the line. Okay? Now, since I want to finish in slope-intercept form, I really have two options. Because look what they've given me. They've given me a slope and a point. So that's enough to get me point-slope form right away. I can just plug in the slope and the point, and that gets me point-slope. But since the directions explicitly stated that I need slope-intercept form, I can write it in point-slope form first, and then just rewrite it into slope-intercept. Or there is a way that I can jump right to slope-intercept. So I'm going to show you both ways, and it's up to you what you want to do. So first, if I have a slope and a point, let's just jump right into using point-slope form. So we'll call this option 1, using point-slope form. This I think is a little bit easier, but you have to make sure that you're good with point-slope form. So remember what it is. Y minus y1 equals m times x minus x1. And I just fill in the pieces. So y minus y1, well, y1 in our case is 4. Remember, x1, y1 is just this point. So it's going to be y minus 4 equals m, which is my slope, that's -2, times x minus x1. Well, x1 is a -3, so when we minus a -3, remember that turns into +3. I would be done if the directions didn't say that I had to have slope-intercept form. If they just said, give the equation of the line, there it is. That's an equation of a line. That's perfectly fine. But since I specifically have to get into slope-intercept form, I can do that from here. All slope-intercept form really has is y is by itself. And then I have an x term and the b on the other side. So all I need to do from this step, distribute that -2. So it'd be -2x minus 6. And then I can add this 4 to the other side. So now I have y by itself on the left-hand side, and I'm left with -2x, -6 plus 4 is a -2. There's my final answer. So I'll just box that off. So that is the equation of the line in slope-intercept form that has a slope of -2 that goes to the point -3, 4. Okay, so I did mention before that there was another option. So option 2, use slope-intercept form. This is better if you, say you're taking a quiz or a test, and you just totally blank on what point-slope form is. Because almost everyone remembers y equals mx plus b, but this one's a little bit trickier. There's a few more things. You might be thinking, is it plus? I can't remember what goes where. So, but kids always remember y equals mx plus b. So, I like this option better because I think it's easier. You just plug the pieces in, but if you don't know this formula, it's not going to help you very much. So, anyway, let's go using slope-intercept form. So that's y equals mx plus b. And there are some things that I know. I know the slope, and this is an x and this is a y. So what I can do is I can plug those 3 pieces in, -2, -3, and 4, in where they go, and I can solve for b. That's the one piece that I don't know, but I can solve for it. So what's y in this, if this is my information that I'm given, what is y in this case? 4. What's the slope, or m? That's -2. And I'm going to multiply that by whatever x is, which in this case is a -3, so I'll put it in parentheses, plus b. I have no idea what b is, but now I can solve for it. So if I just do the math, -2 times -3 is a positive 6 plus b, and if I want to solve for b, I can subtract 6 from both sides, so I get -2 for b. And now I'm almost done. Remember the 2 things that I need. I need the slope and I need the b. Well, I just found out what b is right there. And I knew what slope was from before. So now I can go back to y equals mx plus b and plug in those 2 pieces. Y equals my slope was -2 and b is -2. And if you notice, these 2 are exactly the same. So it doesn't matter which option you go with. I think that this one's a little bit easier, but if you blank out and you don't remember this formula, you're going to have to go this route. Okay? So there's 2 different ways to get the equation of the same line in slope-intercept form. Alright, let's check out what's next. Okay. So here it says, give the equation of the line described in standard form. So let's just recall what standard form is. Down here at the bottom, ax plus by equals c. A, b, and c have to be integers. And we're going to have a, b positive. Okay, so there's not a way for me to jump right to standard form. I'm going to have to put my equation in one of these 2 forms first, and then I can rewrite it so that it's in standard form. Alright, so let's see what we're faced with. Okay, they give me a slope and a point. So which form should I use to start off with if I have a slope and a point? If you said point-slope form, that makes sense to me too, because that's all I need. I need a point and a slope. So, point-slope form, y minus y1 equals m times x minus x1. And let's just plug in the pieces. Y minus y1. What's y1 here? -8. So minus -8 is now plus 8. My slope is 1/2. x minus x1, which is 1. Okay, so I'm almost there, believe it or not. I have the equation of the line. It's just not in standard form as they specifically asked. So I need to get it in standard form, so I need to rewrite this. So it's up to you what you want to do first. Kids always say distribute the 1/2. That's perfectly fine. You can do that. So let's distribute that 1/2. So we're going to get 1/2 x. 1/2 times -1 is a -1/2. Okay? Now, one thing that you want to remember is that I can't have any fractions in standard form. A, B, and C are all integers. That means they're either whole numbers or they're opposites. So I need to get rid of these 1/2s. Can you think of how to do that? Well, we're not getting rid of them. We're turning them into something else. So this is like if you went up to the vending machine and it only took quarters and you had dollars. You just got to change your dollars into quarters so that you can use them. Same thing here. I just need to change these into whole numbers or their opposites. So I need them to be integers. Well, what I can do is I can multiply the whole entire equation by 2. Why by 2? Because that's what my denominator is here. If they were different, say it was a 2 and a 4, you would want to multiply by the least common multiple of 2 and 4, which in that case would be 4. But the least common multiple of 2 and 2 is 2. So I have to multiply everybody by 2. Every single one of these terms gets multiplied by 2. So that really means I have 2y plus 16 equals 2 times 1/2 x is just 1x or x. And 2 times -1/2 is -1. Okay? So we're almost there. We're getting closer. Standard form. I'll write it up here just so we have a visual. ax plus by equals c. So notice how the x and y terms are both on the left-hand side. So look at what I have. I have the x on the right-hand side. So I want to move that x term over to the left-hand side. And then I want to combine the 16 with the -1. So let's just do one thing at a time. If I move the x over, so I subtract x from both sides. So now I have -x plus 2y plus 16 equals -1. And I'm so close, I just want to move this 16 over. So subtract 16 from both sides. I'm running out of room here. So -x plus 2y equals -1 minus 16 is a -17. So, depending on which book or what your teacher wants you to do, this might be your final answer. I have ax plus by equals c. But remember how we talked about the a being positive or negative? So in this case, I have a -a. So if you are required to turn the a into a positive, I'm just going to rewrite what we have over here. So I have -x plus 2y equals -17. If I want to turn this into a positive, I kind of follow the same trick that I did here. Here I multiplied everybody by 2 to get what I wanted. Here, if I want this to be positive, I can multiply the whole thing by a -1. Multiply everybody by a -1. So I'd get -1 times -x is now positive x minus 2y equals a positive 17. And there is a final answer. So it's in the right form. Okay, if we wanted to, we could graph it if we wanted to and make sure that it had a slope of 1/2 and it goes through the point 1, -8. If you just plug in 1, -8, let's see real quick. If I plug in 1 for x, so let's do a little check. If I plug in our point, 1, -8, it had better work. So 1 minus 2 times y is -8. Does that really equal 17? Well, 1 and then -2 times -8 is a positive 16, and 1 plus 16 really is 17. So I do know that my point works in that equation. Okay, so there is my answer in standard form. Okay, down here, same idea. Let me draw a line here so we don't get confused. So here's a new problem. I have one point at 2, -3, and another point at 5, negative 4. So what do I do this time? Remember, I want to end up in standard form. But who am I going to start with now? I have 2 points. This needs a slope and a y-intercept, and this needs a point and a slope. Well, I'm again going to recommend that we pick this one, because I already have this bit of information. I have that. All I need to do is find the slope. And hopefully you remember how to do that. But if you don't, that's okay. I will tell you. The formula for slope is y2 minus y1 over x2 minus x1. Where, here's just point 1 and point 2. It actually doesn't even matter which one you call which. So I like to label it just to remind myself there's x1, y1, x2, y2. So then I can just plug them into the formula for slope. So y2 is negative 4 minus y1, so minus a negative 3 is now plus 3, over x2 is 5 minus x1, which is 2. And now we'll just do the math. So negative 4 plus 3 is a negative 1, and 5 minus 2 is 3. So now I have my slope as negative 1/3. So now it really is a problem just like the one we did above where I have the slope and a point. But here I have the slope and I have 2 points. So how do you know which one to use? Well, conveniently, it actually doesn't even matter. You get to pick. So try and go for the one that looks easier. I'm just going to pick 2, negative 3 because the numbers are smaller. But if either of these were a 0, I would certainly pick that because 0 times anything is 0, so it might make my life a little bit easier. Or if they had 1s in them. I don't know. General rule of thumb, if you just pick the smaller numbers, it'll be a little bit easier, but it doesn't really matter. So I'm going to pick this point. You could have picked this one. Sorry about that, my battery died, but if we just pick up where we had left off, I selected this point here, 2, negative 3. We had found our slope was negative 1/3. So the easiest thing to do is to use point slope form. And then all I had done, remember it's y minus y1. Since y1 is a negative 3, y minus a negative 3 is now y plus 3 equals, my slope is negative 1/3 as we found out over here, times x minus x1, and since x1 is 2, I just plug in a 2 right there. So now I have the equation of my line in point slope form, but I again need it in standard form. So all I have to do from here is just rewrite it so that it's in standard form. So what I could do, I could distribute that negative 1/3. But even easier, I can just sort of skip a step, and since I know I'm going to have to get rid of that, I can't have any fractions, so remember up here how we multiplied the whole thing by 2? I can do the same thing and just multiply everybody by 3, because that's my denominator here. So if I multiply everybody by 3, so remember that's each term will get multiplied by 3, so if I do 3 times y, I get 3y. 3 times 3 is a plus 9. Equals, now since this is multiplication, I only have to multiply the 3 once over here. So 3 times negative 1/3 is a negative 1 times x minus 2. I wouldn't distribute the 3 in here again because that's multiplying twice. Here I had 2 terms. This is really, I have one number times these 2 terms in here. So when I multiply the 3 by the negative 1/3, that takes care of the entire right hand side. Okay, so now if I just keep going, remember I want it to look to be in standard form, so let's distribute that negative 1. So that'd be negative x plus 2, and then I want the x on this side, so I'll add x to both sides. So now I have x plus 3y plus 9 equals 2. And I'll just have to subtract the 9 over. And I'll write it over here because I'm running out of room. So I'd have x plus 3y. And then if I subtract the 9, so I have 2 minus 9, that's a negative 7. And there is my answer. So here's the equation of the line in standard form that passes through these 2 points. Okay? So next, let's talk about a few facts. Okay. So let's start off with, actually let me cover this up as we go. So let's start off talking about parallel lines. Parallel lines look like this. They're the ones that are in the same plane but they never intersect. As far as their equations go, parallel lines have the same slope but different y-intercepts. So exactly the same. So if the slope of one line is -3/4, the slope of another parallel line to that one would also be -3/4. They would be exactly the same. They have to have different y-intercepts because if they were the same y-intercept, then you're just talking about the same line, not two parallel lines. Okay? Perpendicular lines, they look like this. They're the ones that intersect at 90-degree angles. So they might look something like this with the 90-degree angles in there. So perpendicular lines have slopes that are opposite in sign and are reciprocals of each other. So let's talk about that for 1 second. Opposite in sign. So one will always be positive, one will always be negative. Except for our exception that we'll talk about in a second. So one's always positive, one's always negative, and they're reciprocals of each other. So if I told you that the slope of one line was -3/4, the slope of a line perpendicular to that would have to be opposite in sign. So since our original was -3/4, now this is going to be a positive slope, and then I take the reciprocal of 3/4, which is 4/3. So two lines, if the first line had a slope of -3/4 and the other one had a slope of 4/3, they would be perpendicular to each other. And let's take a look at the note. It says all horizontal lines are, this symbol here, the upside down T, means perpendicular. So all horizontal lines are perpendicular to all vertical lines. That's because if you remember, all vertical lines have an undefined slope and all horizontal lines have a slope of 0. So it's hard to take the reciprocal of undefined. So just by definition, horizontal lines are perpendicular to vertical lines. Okay, so let's try a problem using this idea. So this asks us to give the equation in slope-intercept form of the line parallel to y equals 3x minus 2 that passes through 1, 5. So slope-intercept form, first, remember that's y equals mx plus b, so that's, oops, I've got the plus sign. Y equals mx plus b, that's the form I want. I want it to be parallel to y equals 3x minus 2, and it's got to pass through 1, 5. Well, remember what we set up here. Parallel lines are going to have the same slope. So if I want the slope, if I want to create a line that's parallel to this one, I want to have the same slope as this line. Well, do you remember how to find the slope of this line if it's already in slope-intercept form? Hopefully you said whatever that number is your slope, the coefficient of x. So now I know that the slope I need to use is 3 because I want it to be the same as that one. And now it has to pass through the point 1,5. So this is exactly like a problem we did earlier in this video. So I have a slope, I have a point. I might as well use point slope form. Y minus y1, m times x minus x1. And now I'll just fill in the pieces. Y minus y1 in this case would be 5. The slope is 3. X minus x1 is 1. But again, I want slope-intercept form, and this is point slope form. So I'm not quite done yet. I need to rewrite this so that it is in slope-intercept form. So let's distribute that 3. 3x minus 3, and then I'll add the 5 over. -3 plus the 5 would be a positive 2. And there we have it. So this is the equation of a line that's parallel to this one. And we can check real quick. Yep, they both have the same slope, so that's good. And this line will go through the point 1, 5. Okay, let's try another one similar to this. Okay, here I want to give the equation of the line in standard form, so I want standard form this time, that is perpendicular to x minus 2y equals 4, that passes through 6, negative 3. Okay, well, standard form, I know that's ax plus by equals c. A, b, and c have to be integers, so I'm just going to keep that in the back of my mind. That's where I want to end up. Perpendicular, so I know the slopes need to be opposite reciprocals. So if this is my original equation, I have to figure out what its slope is so that I can figure out what the opposite reciprocal of it is. And then once I know the slope, I have my point, I can do what I just did in the last problem. We have some difficulties with this one because I don't know what the slope is just by looking at this. I have no idea, because it's not in point slope or slope intercept form. However, I can rewrite it so that it is in slope intercept form. So what I want to do first is find out the slope of the original line. Okay, so my original is x minus 2y equals 4. If I rewrite this in slope-intercept form, so in other words, get the y by itself, then I can just look at it and figure out what the slope is. So let's do that. I want to get the y by itself. I'll have to move the x over. So now I have a negative 2y, and remember we want to write the x term first, so I'd write negative x plus 4. And now I have to get the y by itself, so I'd divide both sides by a negative 2. So now I have y equals, now I have a negative x over negative 2. So negative over negative is a positive, but I'm going to write it as 1/2 x. And then 4 divided by negative 2 is a negative 2. Now I know the slope of this line. So the slope of my original line is 1/2. So what should the slope of my new line be, remembering that I need it to be perpendicular? And we said perpendicular lines have opposite in sign. So since this one's positive, this one has to be a negative. And I need the reciprocal of this. So what's the reciprocal of 1/2? Hopefully you said 2. So here's the slope that I'm going to use. And they gave me a point. Now I can do exactly what I did in the last problem. So I have my slope I'm going to use, negative 2, and the point is 6, negative 3. So I can do just like in the last one, y minus y1, since it's a negative 3, it's now going to be plus 3. Slope is negative 2 times x minus x1. I want standard form, so I'll distribute that negative 2. And I'm going to need to move the 2x over. So now I have 2x plus y plus 3 equals 12. And just move that 3 over. 2x plus y equals 9. And there it is. It's in standard form because I have all integer coefficients. And we're all set. And then just one last one, because you'll see ones like this all the time, and kids always get stumped on them. But if you remember your facts about parallel and perpendicular lines, and how to graph y equals some number, x equals some number, if you don't, go back to the video on graphing equations of lines where I talk about the slopes and stuff like that. So let's just look at this last one. I need it to be parallel to the line x equals 4. And I need to pass through the point negative 7, 12. Think about what that looks like. How do you graph x equals 4? Hopefully you remember that x equals 4 will be a vertical line at 4. So, parallel to a vertical line, wouldn't that have to be another vertical line? Yes. And all vertical lines have the equation x equals whatever the x value is. Well, what's the x value here? Negative 7. So if you understand all those things, I can jump right to the answer. There's not really any Anything else I need to do? It's got to be parallel to this line, and it's got to pass through this. What if I had said perpendicular instead of, so let's just do perpendicular to x equals 4, passing through the same point? How would your answer be different if I had said perpendicular? Because now, remember we said in the note before, all horizontal lines are perpendicular to all vertical lines. So, I know x equals 4 is a vertical line, so I need a horizontal line that goes through this. What's the equation of any horizontal line? It's always, let's do orange, y equals whatever the y value is. So if I had asked you perpendicular to that, through that same point, it would be y equals 12. Okay, I hope this helps you write some equations. Good luck!